Hello and welcome to Mr. Linford's math course. In this presentation, we're going to talk about interpreting statistics from tables and different graphs that you might commonly see. In particular, we're going to talk about dot plots and histograms or bar graphs, and then we're also going to look to see how we can more accurately read tables for key information. First up, let's talk about one of the more common types of graphs or plots that you would see when working in statistics, and that is the dot plot. Now, a dot plot is a statistical chart. Keep in mind, it's a chart where dots, yes, we are using dots in a dot plot. It's a statistical chart where dots are plotted over data values to track the frequency of each data point in the full data set. What do we mean by frequency here? To track the frequency, I'm going to also use the phrase occurrence. We want to track how frequently something appears or how much it occurs in the data set. That's what a dot plot does. So take a look at this data set here. We have 1, 3, 3, 4, 5, 5, 5, 6, 6, 8, 9, 9, and 9. We could just list this information out, this data out, and just have it listed out horizontally. But it's sometimes nicer to present it in a dot plot. And what I mean by that is take all the data that we have, 1 through 9, which is essentially what we have here, and that's going to be on our x-axis. On our y-axis here is the frequency. How often do these numbers occur? So take a look at the number 1. How often do you see the number 1 in this data set? Well, I only see it this single time. So the number 1 occurred one time. That's why I put a dot right here. For the number 1 occurred one time. It had one frequency in the data set. Take a look at, well, first off, do you see anything for number 2? No, so we're going to leave this whole area blank. But how many 3s are there? And we see there are 2 of them. So I'm going to go and say there's a 3 and then another 3. There's 2 of them. So I mark a dot for each time I see that same number. Number 4, there's only 1, so I'm just going to put a single dot right here. But for 5, there are 3. So, okay. Put a dot for the 1 5, a dot for the other 5, and a dot for the third 5. So altogether, we have 3 dots here. Now for 6, there's 2 of them. Again, I go 1, 2. There's nothing for 7, so this whole area I'm going to leave blank. But 8, there's just 1. And then there are 3 9s, so let's keep track of that. 1, 2, 3. And there, this is me creating a dot plot to represent the data. Keep in mind that a dot plot is showing the occurrence or the frequency of each of these data values. So how often are these values occurring? That's what we use a dot plot for. How often are these values occurring? We can see that the numbers 5 and 9 occurred the most. Things like 1 and 8 and 4 occurred the least. And in fact, things like 2 and 7 were not even a part of the set. So that's what a dot plot shows us. It really demonstrates the frequency or how often values occurred. Take a look at this example here. We have in this situation an appliance salesman keeping track of how many appliances he sells in a day. Over the course of 13 days, he creates this dot plot to chart how many times he sells different amounts of appliances. So we see here on this axis the number of items sold. And we see, how many times he sold these different items. So if he sold 7 items, he put a little X right there. If he sold 8 items on a day, he put a little X right there. If he sold 6 items on a day, he put an X there, and if another time he sold 6 items, he put another X, okay? What this is telling us is these are the numbers of items sold, and this is how often it occurred. So, think about these 2 questions here. How many days did he sell only 1 appliance? Was there a day where it was rather slow and he sold only 1 appliance? And how many days did he sell 6 or more appliances? Keep that phrasing in mind, 6 or more. What I want you to do is pause the video and take a minute to read through these questions and interpret the dot plot here. Remember, a dot plot's telling us how frequently these values are occurring in our data set. How often did these events occur? Okay, so pause the video, take a couple minutes to answer these, and we'll see what you come up with when we return. All right, well, hopefully you had some time to work through this problem. The first one can be a little bit tricky because what I'm testing you on here is how you're interpreting the dot plot. How many days did he sell only one appliance? Now, a lot of times people would say, well, look here, 1, 2, 3. 3 days he sold only one appliance because there's only 3 times where one thing is occurring. But I want to, that's not really correct. I want us to avoid that thinking, and I want us to really think back to what does it mean to be a dot plot? And what does it mean to have each point represented on the dot plot? This number right here, 8, means that on a single day, he sold 8 appliances. This right here for the number 7 means one of the 13 days, he sold 7 appliances. Having 2 marks here indicate that there were 2 out of the 13 days that he sold 10 appliances for each of the days. The thing about a dot plot is it doesn't tell you the days over time. This isn't like day 1, day 2, day 3, day 4, etc. More so, it just keeps track of, out of the total number of days, how many times did he sell 6 items? How many times did he sell 4 items or 3 items? So, how many days did he sell only one appliance? Well, let's take a look. This is the area where we would mark if he sold a single appliance. There is no marking there. So, no days. There is no time in the last 13 days where he only sold one appliance. There were 2 days where he sold 3 appliances, 3 days where he sold 4. One of the days he sold 5, one of the days 7, one of the days 8. That's what we're saying here in the dot plot. It's a little different because it doesn't really represent time, more so it represents occurrence. How many times did he sell 3 items or 4 items or 5? So when we say how many times did he sell a single item, well, there were no days where he sold just one item. Instead, he sold often more than 3. So that's what we're saying here in the dot plot. So let's use that thinking when we try to answer this next question. How many days did he sell 6 or more appliances? Well, let's take a look at 6 appliances. There were 3 days where he sold 6 appliances exactly. 1, 2, 3. Now, we also want to know, did he sell more than 6 appliances? Yeah, one day he sold 7. One day he sold 8, another day 10, and in fact a second day he sold 10 appliances. So how many days did he sell 6 or more? Well, 1, 2, 3, 4, 5, 6, it looks like 7. 7 of the 13 days he sold 6 or more appliances. So let's go ahead and indicate that, 7 days. And again, we're including 6 here, so we're saying how many dots are right there, okay? Again, the dot plot doesn't really keep chronological track of anything. More so it says, okay, of all these days, how often were you able to sell a certain number, okay? That's what we're saying here in the dot plot. Now let's change up some of our exploration to talk about a different way of representing information that you might frequently see in statistics, and that is the histogram. Now, a histogram is a more technical name for a bar graph. A histogram is a statistical bar graph, okay, keep that in mind. Now we're using bars in our data, where the frequency of occurrence of data points in a data set is represented by the height of bars. Okay, so we're using the height of bars to indicate the frequency of how often data is occurring. Does that sound kind of familiar? Well, wait a minute. Wasn't a dot plot basically us plotting dots to show the frequency of data, and now we're using a bar to show how frequently data occurs. What I want you to understand here, a histogram and a dot plot are essentially going to be the same thing, okay? Pretty much a histogram and a dot plot are basically going to show the same data. It's just one's showing by dots and one's showing by a bar graph. So let me write here, same as a dot plot, but with a bar graph. So it's just going to be changed up a little bit in the way in which we draw it, but it's the same information. It's telling you the same thing. Sometimes, though, histograms or bar graphs are a little easier for us to read than dot plots. It depends on your audience and which way you want to represent the information, but sometimes histograms and bar graphs are a bit nicer. So I have the exact same data set as before. The 1, the 3, the 3, 4, 3 5s, 2 6s, an 8, and 3 9s. And I want us to recreate this graph, but instead of doing a dot plot, we're going to do a bar graph. I'm going to try my best to draw this here. Now, the number 1. The number 1 only occurs one time in the data set. So again, we're saying how often is the frequency? How often are these numbers occurring? So how often does the number 1 occur? Well, it only occurs one time in the data set. You know what? Let me try it like with this color, blue. So I'm going to make a bar here where the value 1 only has a height of 1. Okay? Now 2, how often does 2 occur in the data set? Well, it doesn't. So I'm not going to draw a bar there. It has a height of 0, so I'm not going to draw anything. Now take a look at 3. How often does 3 occur in the data set? Well, 3 occurs twice. So I'm going to have a bar that's a height of 2. 4 only occurs once, so I'm going to have a bar of only 1 height. Now 5 occurs 3 times, so that bar is going to go up 3 values. Let me try to draw that a little nicer. 6 goes up 2 values. 8, I should say 7. There is no 7, so it's got a height of 0, so I won't draw a bar there. But 8, again, is only once, so I have a bar of 1. And 9, there are 3 of them, so I go up 3 values. I should probably color these in. Let me see if I can draw that a little nicer. But this is what a histogram is doing. It's basically the exact same thing as a dot plot, but the thing is we're using bars instead of dots. And also, you'll notice that my axes look a little different. That's because if I'm going to draw bars, I need to have them a little thicker. So instead of having the 3 on like the tick mark, it's kind of in between. So there's a little bit of drawing differences that you have to do, but they're essentially the same thing. In fact, go back and take a look at the shape that we have here for this graph compared to the shape that we had for the dot plot. You'll see that really we have the same shape for the dot plots that we did for the histogram. It's the exact same setup of what's going on here. Let's take a look at an example now where we have to interpret information from a table to help us answer different questions about specific data points that we have throughout the table. So, before we begin, I want us to kind of understand what this graph is telling us, or what this table is telling us. We have 4 different bookshops here: Bob's, Clara's, Derek's, and Evelyn's. Now, we're keeping track every day of the week of how many total sales they made. So, each of these numbers represents the number of books that were sold at the different shops for different days of the week. For example, Derek's shop on Wednesday sold 12 books, while let's say Clara's shop on Friday sold 7 books. So hopefully this is making sense to you. We're just tracking for each of these bookstores how many books were sold for each day of the week. The total columns are what I want us to look at next here. The total column and the total row. Because this is sometimes where students get a bit confused. What do these different totals mean? Let's start by looking at the total column here. This total column is adding up every day of the week's total sales. So we're seeing here how many total sales were made on Tuesday and Thursday and Friday and Monday and Wednesday. That's what we're seeing with this column here. It's adding up all these row values. So let's take a look at Wednesday. Wednesday, Bob sold 10 books, Clara sold 13, Derek sold 12, and Evelyn sold 14. In total, there were 49 sales on Wednesday. Take a look at Friday. At Friday, Bob sold 13, Clara sold 7, Derek sold 10, and Evelyn sold 9, for a total of 39 books sold. What this column is telling us is, over the days of the week, how many books were sold for each day across all 4 shops. So we can see things like, oh, it looks like Tuesday and Wednesday was the most profitable because most of the books were sold throughout the 4 shops on Tuesday and Wednesday, while Friday looked to be the slow day for most of the shops. Now, the row totals are a little different. This is adding up all of the individual bookshop sales for the week. So, for example, the number 53 here is adding up all the Monday, Tuesday, Wednesday, Thursday, and Friday sales for just Bob's shop. The number 58 over here is adding up the 12, 13, 14, 10, and 9 sales that were made throughout the week at Evelyn's shop. So keep in mind that these values on the end of the rows here really represent how many books were sold for each day of the week across all 4 shops. So we were specific in the day of the week, but we added up all 4 shops. Versus, we're saying, okay, focus on one shop, but add up every day of the week. So we're being specific in general with different things here, with the different variables that we have. So, keeping that in mind, let's try to see if we can pick out specific information from this table to answer these 2 questions. The first question says, which of the 4 bookshops, so which of the 4, we're trying to find which specific one, made the greatest fraction of total sales on Tuesday? Which of the 4 bookshops made the greatest fraction of total sales on Tuesday? That's a little weird, isn't it? I mean, the greatest total sales on Tuesday would make sense. Which of the 4 shops sold the most books on Tuesday? Well, it would look like Derek did. It would look like Derek sold the most number of books because he sold 15. But that's not what we're being asked here. We're being asked on Tuesday who had the greatest fraction of total sales. So if we're thinking about this, we have Bob, Clara, Derek, and Evelyn all selling different amounts for the most part on Tuesday. Bob sold 8, Clara sold 13, Derek sold 15, and looks like Evelyn sold the same as Clara, 13 books. And like we were saying, well, Derek sold the most. But we're asked to find who sold the most in terms of their total sales. Okay? Of their total sales, who sold the higher amount in relation to their total sales? So Bob sold 8 out of 53. Clara sold 13 out of her total 55. Derek sold 15 out of his total 66, and Evelyn sold 13 out of her total 58. What we're asked to find here is, what's the greatest fraction or the greatest proportion that we have here. Is Derek selling the most? Yes, he sold 15, but is he selling the most compared to the total sales that he made? Who had the greatest proportion of sales on Tuesday? Now, you can look at this and you might say, okay, we're working with 4 different fractions and we're trying to find which fraction is the biggest. So you would need to do what? Well, hopefully you're saying we would need to have a common denominator here, because I can't just eyeball 15 out of 66 compared to 13 out of 55 and decide which of those is bigger. I'm not sure on that. I have a guess, but I'm not 100% positive. So I would need to have all of these be common denominators. Oh my gosh, that's going to take a little while, right? Think about what we're saying here. The greatest fraction of total sales, the greatest proportion of total sales is another way we can phrase a fraction, right? A fraction represents a proportion. It also represents a percentage. Proportion, fraction, percentage. We can all kind of say they represent the same thing here. So 8 out of 53, 13 out of 55, 15 out of 66, 13 out of 58. Let's divide those and see what percentages they are. What percent is 8 out of 53? Well, 8 divided by 53 is 0.15, so that's 15%. What we're saying here is of Bob's total sales, 15% of them were made on Tuesday. So 15%. For Clara, we had 13 out of 55. 13 out of 55 is 0.236, so that's 23.6%. We can even round that up to 24. So Clara, of her total sales, 24% of her total sales were made on Tuesday. Now, for Derek, it was 15 out of 66. That should be about 22.7%. We can round that up to 23%. So 23% of Derek's total sales, of his total sales, 23% were made on Tuesday. While for Evelyn, the 13 out of 58 gave 22.4%. So let's just say that's 22% of her total sales. So 22% of Evelyn's total sales were made on Tuesday. Yes, Derek sold the greatest number of books on Tuesday. However, when we consider how was that in proportion to your total sales, of everyone's total sales, who had the greatest fraction or the greatest percentage of their total sales made on Tuesday, we can see that it was Clara. Clara had the greatest percentage of total sales or the greatest fractional amount of total sales. They really mean the same thing here. So we're going to say Clara had the most percentage of sale, had the greatest percentage of the greatest fraction of sales on Tuesday. Hopefully you're seeing how that is different than the greatest number of sales. There's a little trick for you to help out. When we say the greatest fraction of total sales, I want you to think proportions. I want you to think percentages. Something that's a little easier for us to interpret and a little easier for us to do than try to find the common denominator between 53, 55, 66, and 58. That might take a little while. Now let's take a look at the second problem here. What fraction of all the books sold on Monday, Wednesday, and Friday were sold at Derek's and Evelyn's? So let's get a little picture of what's going on here. We're asked to look at multiple days. We're asked to look at Monday, Wednesday, and Friday. Monday, Wednesday, and Friday. And then we're also looking at Derek and Evelyn's bookshop. So Derek and Evelyn's bookshops. Okay. We need to find what fraction, so again, we're dealing with a fraction here, of all the books sold on these 3 days were sold at Derrick's and Evelyn's. So what fraction of all the books sold on these 3 days were sold at Derrick's and Evelyn's? Well, 48 were sold in total on Monday, 49 on Wednesday, 39 on Friday. These are the total values sold for Monday, Wednesday, and Friday. What fraction of these were sold at Derrick's and Evelyn's? So I don't really care about Clara or Bob's sales. More so I'm looking at, okay, here were the total sales for Monday, Wednesday, and Friday. Here's how many were sold at Derrick's and Evelyn's. Try to come up with a fraction that represents, of all the total sales, how many were sold specifically at Derrick and Evelyn's for these 3 days. Pause the video, take a couple minutes to try to figure this out, and let's check back in to see what you get. All right, well, hopefully you're able to work through this problem and try to interpret the different categorical values that we have going on here, interpreting Derrick and Evelyn's total amounts versus the total amounts in general. So first off, I think it's helpful for us to really try to quantify the total number of all books sold on Monday, Wednesday, and Friday. Okay? We're not distinguishing between days here. We're just saying all those on Monday and Wednesday and Friday. Add them all up, which I did here, and I got 136. So of those 3 days, 136 books were sold in total. We're asked to find how many of those total sales were made by Derrick and Evelyn. Well, let's see. Derrick and Evelyn on Monday sold 15 and 12 books, so that's a total of 27. Let me try to write that. Let's see, 27 on Monday. On Wednesday, we had 12 and 14, which is 26. I know it's getting a little messy here. And on Friday, we had 10 and 9, which is 19. So Derrick and Evelyn sold 27, 26, and 19 books to all together on these 2 days. So let's see, what is that? 27 plus 26 plus 19. That gets us 72. So all together, when we added up the Monday, the Wednesday, and the Friday sales, we get 72 books. That means Derrick and Evelyn sold 72 out of 136 books on Monday, Wednesday, and Friday. If we wrote that as a percentage, by the way, if we just divided that, it would be 52.9, let's say 53%. So we could say on Monday, Wednesday, and Friday sales, over half of them were due to Derrick and Evelyn. You could say that. But that's really what we're being asked here, is to come up with the fraction. So I'm going to go ahead and erase the percentage. We want to make sure we're giving the answer that we're directed to. So if they want a fraction, we're going to say what the fraction is. 72 out of 136. Derrick and Evelyn's amount over the total amount made on Monday, Wednesday, and Friday. Again, things to look out for here. Really paying attention to which of the total columns we have to work with here, okay? Remember, you're asked to find the total sales for Monday, Wednesday, and Friday. Those are from this value, this total column, not these values here. But I'll tell you, I see this happening quite a lot, where people mix up these values with these values. So we want to be careful with that. We want to make sure we're understanding where the information's coming from and where to pull that information from the different tables. All right, let's take a look at this problem. A little different setup. This time we have a bar graph. Now this bar graph represents a sleep study that was conducted on a person. Now, when people sleep, they experience various types of brain activity. Scientists have classified these types of activity into 4 sleep stages. Sleep stage 1, 2, 3, and 4, also known as REM sleep. Now, stage 3 is the only stage considered to be deep sleep. Okay, so stage 3 is when you're in deep sleep. Now, suppose a person went to a sleep clinic to have his or her sleeping brain waves analyzed. That's a real thing. You go into a sleep clinic and you sleep throughout the night and they monitor your brain waves. Now, a technician that monitors the person's brain waves does so in a 15-minute interval. So for, 15 minutes, they see, okay, where were you at in your brain waves? Then for the next 15 minutes, okay, now I'm going to measure again. Then I'm going to measure you again in another 15 minutes, okay? They did this for 8 continuous hours and then categorized each of those 15-minute intervals into one of the 4 stages of sleep. The bar graph below shows the results of 1 night of study. Take a look at this graph and let's see what we can interpret from it. This is the 8-hour sleep study results, okay? We have, and let me change colors here so I can highlight a little better. We have a series of bars on the graph here. Each bar represents 15 minutes of time. Altogether, this is an 8-hour sleep study. So each of these bars, that's 15 minutes, that's another 15, that's another 15 minutes, that's another 15. In fact, that's probably an hour right there, right? These all represent time. We're told that right here. Now let's figure out what the other axis represents, okay? It tells us that these are the sleep stages. This is stage 1, stage 2, stage 3, and stage 4. So let's just pick a random point on the graph here. Okay, let's take this point. This is a point in time in the night. In fact, it's somewhere in the middle of the night. For this 15-minute interval in the middle of the night, it corresponds to sleep stage 1. So at this point in time, the person was in stage 1 of sleep. Hopefully you're seeing here that these stages of sleep are cyclical. You go in and out of the different stages of sleep. From, stage 1, 2, 3, back to 1, 2, 3, back to 1, 2, 3. It's a cycle, okay? How many minutes did the patient spend in non-deep sleep over the entire night? So we're going to look at the entire night here, and we need to identify how many minutes did they spend in non-deep sleep. I think one of the first things we should ask ourselves is, what is non-deep sleep? What is that? Pause the video, take a minute, reread this problem, and see if you can identify what is non-deep sleep. So we're asked to find what is non-deep sleep for this problem. Hopefully you're able to point out in the passage here it says, stage 3 is the only stage considered deep sleep. So anything else would, we could assume, be non-deep sleep. So let me make a note of that. Non-deep sleep is anything in, let me say non-deep would be anything in stage 1, 2, or stage 4. So anytime you're in one of these, stage 1, 2, or 4, you're in non-deep sleep. It's only when you're in stage 3 that you're considered to be in deep sleep. We need to find how many minutes did the patient spend in this non-deep sleep. Can you pause the video for a minute and try to see if you can identify areas on the graph where the person was not in deep sleep? See if you can identify those areas on the graph. I'm going to do it with a highlighter, but pause the video, give yourself a couple minutes, and see what you come up with. All right, well, hopefully you had some time to work through and play around with the graph and see all of these areas that I've highlighted are the areas that in time where the person was not in deep sleep. The only time someone's in deep sleep is if they're in stage 3. So for the first 15 minutes of sleep, the first 15 minutes here, the person was in stage 1. For the next 15 minutes, they were in stage 2. And for the next 15 minutes after that, they were in stage 2. So they spent the first 15 minutes in stage 1, the next half hour in stage 2. It was only after, 45 minutes that they entered stage 3. And they were in that for half an hour. So all of these bars represent 15 minutes of time. And it's chronological. This is throughout the night. This is start of sleep, and this is when you would wake up. Okay? And each of these bars are 15-minute intervals. How many of these intervals are non-deep sleep? So how many of these intervals did I color? Well, let's see. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Did I color 20 of these? Well, it looks like that. So you could say 20 intervals were in non-deep sleep. But is that what we're asked to find? No, we're asked to find how many minutes. Well, if each of these intervals is 15 minutes, each of these bars are 15 minutes, and I colored 20 of them in, just multiply. 20 times 15. And you get 300. So it should be 300 minutes. 300 minutes you spent in non-deep sleep. And this is us just going through and counting up how many times, how many intervals, or how many bars there were of essentially that weren't at a height of 3. How many bars didn't stop at this line? Now that's one way of going about finding this. Could you have maybe done an even quicker way of figuring out the total number of non-deep sleep? Some people would say, that's fine to add up all these times, like to actually go through and figure out how many intervals you are in non-deep sleep, but there's quite a bit of them to count, and this is kind of a tiny graph. Maybe instead of counting the non-deep sleep, count how many times you were in deep sleep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You were in non-deep sleep. I'm sorry, I should say you were in deep sleep. My bad. You were in deep sleep 12 of the 12 times. 12 little intervals, right? You were in deep sleep. Let's see. 12 intervals, and each interval is 15 minutes. So what is that? 180 minutes. So for 180 minutes, you were in deep sleep. Well, if all of this is 8 hours, and 108 minutes of that was deep sleep, how many of it wasn't deep sleep? Pause the video. Give yourself a little challenge. See if you can come up with it. You spent 8 hours in sleep. 108 minutes of that was deep sleep. How much would non-deep sleep be? Well, if you're in 8 hours, which, let's see, 8 hours, and there's 60 minutes in an hour, so 8 times 60 is 480 minutes. So in total, we have 480 minutes here. You spent 180 of those in deep sleep. So how many did you spend in non-deep sleep? Well, if you just subtract these, let me get some room here, 480 minutes of the total minus the 180 minutes you spent in deep sleep leaves 300 minutes for you to be in non-deep sleep. Here's another way we could go and solve this problem. Again, both of these ways are valid. It's up to you to decide which technique you like to use. Do you want to use the graph to just go right ahead and compute how many times we're in non-deep sleep? Or do you want to use the graph to say, okay, let me find how many times I was in deep sleep and just subtract that from the total amount? Again, what's very key to any of these techniques that we do is making sure we understand the graph. understanding what each axis represents. You should always do that first. Look at your graph. Understand, okay, what's the x-axis telling me? Each bar is 15 minutes, so we're going from the start of our night to when we wake up in 15-minute intervals. What is the y-axis telling us? That's the sleep stages. So, when was I in stage 1? When was I in 2, 3, and 4? Even the title will tell us some information. This was the 8-hour sleep study, so I know in total it's been 8 hours. So now I understand that each of these little boxes of time, each of these bars, represent 15 minutes throughout the night. And each of them their height represents, in that 15 minutes, what stage were you in, okay? So, hopefully this is starting to make sense to you. Hopefully you're feeling comfortable interpreting these graphs, interpreting the tables that we have here, and hopefully you're able to pull the necessary information from them. If you have any questions about the video and the content, or if you have any comments about the content, please let me know. My email is klinford, that's KLINFORD, at wccnet.edu. Let me know what you thought of the video, if you have any questions or comments, and until next time, take care.